Hi, good morning, friends. All right, so if you're watching this video, you are in group 2, which means that you are going to part 2 of our lesson with solving systems by elimination. Last few days, we've just been working on a system that was ready to eliminate right away. Today, in part 2, we're going to introduce one little extra step that you're going to have to do before you can eliminate. So let's quickly review by going over what we talked about in the bell work here. So remember that we can use multiplication to make these numbers match, and you're going to see why in a few minutes. So if I wanted to get this 5 to match a 25, remember that we could multiply it by 5, which will get us to 25. And then we just rewrite this, and now they match. If we have the numbers 12 and 4, I know that I can multiply 4 by 3, and now I have 12, which is great because that matches our top number here. Good, these match. With 5 and 6, though, there's not really an easy way to get that 5 to match the 6 or the 6 to match the 5. But I know that both 5 and 6 go into the number 30, so we can actually multiply both of them to get there. I know that 5 times 6 gets me to 30, and 6 times 5 gets me to 30. Now these match, and that's going to set us up for success today. This whole week, we've been working on systems that look like this, where we know that we're going to take one of our variables, whether it's X or Y, eliminate it, and go through and solve. So if I was looking at this system, ask yourself which variables right now are ready to eliminate. And after you look at it, you see that you've got this 4x and the 4x. The coefficients 4 and 4 match, which means that we can eliminate them. And because they're the same sign subtract, we'd subtract going down, and then we can go through our solving process. Today, our focus is going to be on systems that look like this. Do you have a variable that's ready to eliminate right now? Do your x's match or do your y's match? No. The answer is no. However, we can use multiplication as a tool to get our coefficients to match. Look at our x's. Is there a way that I could get this 2 to match the 4? What could I multiply 2 by to get to 4? Please say that you're saying 2 in your head. What we can do, and I'm going to teach this to you today, is multiply every single term in this equation by 2. And watch what happens when I do that. 2 times 2x gets me 4x plus 2 times 3y gets me 6y equals 2 times 20 is 40. Now I didn't do anything to my top equation, so I just rewrite it right on top. Now, do you have variables that are ready to eliminate? Take a look. You have 4x and 4x. Now these match, and you can go through and solve by elimination like you know how to do. That is what we're going to be working with today. In your notebooks, go ahead and write this title down, and you're going to follow along with examples from me. I will walk you through 3 examples. Maybe you want to watch one of them and then write down 2. Maybe you want to write down all 3. It's totally up to you. But just make sure that if I'm going through an example and you're like, wait, what did Miss Amanda say? Pause it, rewind, go through it again. Go slow. Work on your understanding here. Okay, and remember, this is part 2 of solving systems by elimination. And here we go. Here's example number 1. Notice our checklist stayed the same, but we added our new step right here where we have to multiply one or both of those equations to get our coefficients to match. Okay, so look at right here. Question number 1, do you have variables that match? Can we eliminate right away? I see a 4x and a 2x, and I see a negative 2y and a 1y. So it doesn't look like it, which means that we're going to have to multiply. It doesn't matter if you want to get your x's to match or your y's. I'm just going to go ahead and kind of use what we did in our example. I'm going to get our x's to match, which means that I need to multiply every single piece of this equation by 2. And notice this is kind of like the distributive property. So I've got 2 times 2x, which gives me 4x, 2 times y, which is 2y, and 2 times 6, which is 12. I didn't do anything to my top equation, so I'm just going to rewrite it right on top here. Okay, now here's what you've got. Okay, well, first of all, check. That's done. This actually kind of worked out kind of cool. You could either eliminate your x's because you have 4x and 4x, or you can eliminate your y's because you've got minus 2y plus 2y. It doesn't matter, they match. Let's say that I'm going to eliminate my y's. Let's say I'm going to do that. So here we go. I see that I've got minus 2y plus 2y. Because those are opposite signs, we're going to add our equations here. So these go away, they eliminate. And I'm going to add going down. 4x plus 4x gives me 8x. Remember, these are gone. Equals 4 plus 12 is 16. Now I just divide both sides by 8, and I get that x is equal to 2. And you've already solved for one of your variables. Plug that into your solution right away. Now I have x, I just need to solve for y. You can use either equation to do so. I always go back to my original ones. Yes, it's okay that we multiplied over here, but when I'm checking and I'm trying to find my other variable, I always go back to my original solution. So I'm just going to use my second equation. And instead of x, I'm going to plug in the solution that I just got. I found that x was 2. I plug in x for 2 here. Now I just go ahead and solve my equation. 2 times 2 is 4, plus y equals 6. To isolate y, I'm just going to subtract 4 from both sides. And when you do 6 minus 4, you get that y is equal to 2. And remember, we plug that into our solution. That is your final coordinate pair. So this system, when we solve by elimination, it's the same as what we've been working on all week. We just had to add an extra step where we multiplied to get our x's to match or our y's to match. Let me show you again. All right, so take a look at the system that we have. Currently, we don't have variables that are ready to eliminate. We don't. But we can use multiplication as a tool to help us. Let's say, okay, so since we eliminated our y's last time, let's eliminate our x's this time. How can I get a 1x to match a 2x? What would I multiply this entire equation by? Hopefully in your head you're saying 2, because that's what we're going to do. So we're going to multiply 2 by every piece in this equation. So 2 times 1x gives me a 2x, plus 2 times y is just 2y, equals 2 times 3, which is 6. I didn't do anything to my top equation, so all I have to do is just rewrite it. Now, do you have variables that are ready to eliminate? I see that I have a 2x and a 2x, which, okay, good for us. First of all, we already multiplied. We can eliminate our x's, and because it's a positive 2x, those are the same sign, we are going to subtract going down. So these eliminate. 3y minus 2y is 1y. 5 minus 6, be careful, is a negative 1. So really, y is just equal to negative 1. Go plug that into your solution right away. Now, for us to solve for x, we can use either equation to do so. In my mind, this one kind of looks easier. So all I have to do is just rewrite it. Instead of y, I'm going to go ahead and plug in this negative 1. And instead of a minus 1, to solve for x, we're going to do the inverse, which means that we'll add it to the other side. And when we do that, 3 plus 1 is equal to 4. And then we just plug it into our coordinate pair here, and that's our solution. In both of the examples that I've gone over so far, we only had to multiply one of our equations to get our x's to match or to get our y's to match. The last example I'm going to show you won't exactly be that easy. Right now, is there an easy way for us to get a 2 to match a 3 or a 3 to match a 5? Is there a way we could only multiply one of those equations? No. No. This is like our bell work example where we had a 5 and a 6, and we had to find a number that both of those went into, and we would multiply both equations to get to that common numerical value. So pick, are we going to use x's or y's? Okay, well, I'm going to pick for you. We're going to use our x's here. We're going to use x. What's a number that both 2 and 3 can go into? It's going to be 6. So to get a 2 to a 6, we're going to multiply every piece of this equation by 3. So watch how I do that. Okay, 3 times 2x gives me a 6x plus 3 times 5y is 15y equals 3 times 12 is 36. Okay, that one's good to go. For my bottom equation, how can I get a 3x to match a 6? What do I need to multiply by? In this equation, we're going to multiply everything by 2. And remember, it's kind of just like distributive property. 2 times 3x gives me 6x. Okay, first of all, yay. We can see that we have matching coefficients now. That's good for us. 2 times 3y is 6y. And 2 times 9 is equal to 18. Look at our system. We now have variables with coefficients that match. We've got our 6x and we've got our 6x. That's great. That's good. That's what we want. So we did our job. We multiplied to get our coefficients to match. We know we're going to eliminate our x's. Now, because it's a positive 6x, positive 6x, those are the same signs that we'll subtract on the way down. Now, these eliminate. Good, that we did our job. 15y minus 6y, take a second to calculate that. You should get 9y. 36 minus 18, take a second to calculate. You should get 18. Now, this is just a simple one-step equation. Divide both sides by 9 to isolate y, and you get that y is equal to 2. Go plug that in here right away. Don't lose it. The very last step, we know what y is. We need to solve for x. Go back to one of your original equations and rewrite it so that we can plug in y to solve for x. I'm just going to use the bottom one. It doesn't really matter. You'll get the same answer, but I just chose that one. Now, instead of y, I'm going to take out that variable, and I'm going to plug in this 2 here. And now we pretty much just go along with our solving process. We've got 3x plus 3 times 2 is 6 equals 9. We want to isolate 3x because we're trying to solve for that variable. To move this plus 6 to the other side, we perform the inverse operation, which means that we subtract it. And now we're left with 3x equals 3. All we have to do is just divide both sides by 3, and we get that x is equal to 1. Plug it in your coordinate pair, and you did it. So ladies and gentlemen, when you're solving a system by elimination, there are some times when you have variables that match with their coefficients, and you can eliminate them right away and go through and solve. There are other times where you have to use multiplication to make those coefficients match. Sometimes you can get away with just multiplying one of the equations, like in our first 2 examples. Other times you're going to have to multiply both to make sure that we get those coefficients that match. All right, everybody. Really nice job. You go ahead and move on to your Schoology check. And if you have questions, you ask me. Awesome work. Thank you.